Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. In today's lecture, we are going to discuss a very important topic, and that is total internal reflection. This topic will lead us to the understanding of optic fiber, which is the last topic of this unit. So let's get started. In the previous section, we have basically looked at only situation where light passes from a less dense medium to a denser medium. We shall now investigate more closely the behavior of light when it goes from a denser to a less dense medium. Means that we will learn the reverse phenomena. We shall follow a step-by-step investigation of what will happen when the angle of incidence of light in a denser medium is progressively increased. So we have to study it step by step. Now the first step, the figure is shown to you people. There is a semicircle of the glass block, and there is a ray box, and there is a light ray passing from point O, which is normal. So the angle of incidence in the denser medium is increased by moving the ray first. First we will discuss that direct a narrow ray of light normally through the semicircular glass block. The light ray passes through without any deviation, and you know this from the previous section. Whenever we direct a ray at normal from a rare medium to a denser medium, then the ray is passing without any deviation, as you can see that here as well. So that was the first step. Now in the second step, what we will do, the angle of incidence in the denser medium is increased by moving the ray box on an arc of a circle central at O. The light ray enters the semicircle block at E without any deviation. However, when the ray is incident at O at an angle, say I, the ray will leave block and is refracted away from the normal as it is traveling from a denser to a less dense medium. Actually, what is happening now, we have to move the light ray box, as in this case it was normal, but here we have to move it on the semicircular path as in this case. So when you are moving, when you are directing this ray and it is hitting the I portion here, it will go straight, but when it is going out, it will deviate from the normal, and that is the refracted angle. So this is the I, and this is also internal reflection. Remember and pay attention that whenever there is a ray passing from a denser medium to a rare medium, then there is a very weak reflection as well, as we can see it from here. That is not totally visible. So keep in mind that there is a reflection, but internally the reflection is very small. And all the laws of reflection are also applicable to this. So this I and this I will be equal to each other. So whenever you are directing a ray, it will not deviate, it will pass through the O, and whenever it is getting out from this denser medium to a less denser medium, so it is quite natural that it will deviate from the normal, and that is what is happening in this particular case. So the angle of incident from a denser medium, when we increase it by moving the ray box on an arc of the circle of centered at O, the light ray enters the semicircular block at E without any deviation. Now in the third step, we have to increase the angle of incidence until it is becoming parallel. Let me explain this, that in this case, if we are increasing this ray, so it will deviate further. If we are increasing this angle, this ray box moving more on this arc, so a time will reach that it will be parallel to the surface of circular, semicircular block. So that is what we did here. We increase the angle of incident, and it will be at 90 degree, as you can see from here. It is written also that it will be at 90 degree. Now the incident ray I is changed by C, and that is called critical angle. That is called critical angle. What is critical angle? We will define it in a moment, but let's first understand the angle at which the incident ray becomes perpendicular to the normal. This is the normal, and now this is the 90 degree for it. Then at that situation, the angle will call critical angle. So as the angle of incidence is increased further, there will reach a critical value when the angle of refraction in the less dense medium or becomes 90 degree. The angle of incidence at which the angle of refraction is 90 degree is known as the critical angle, denoted by C. Now if we further increase, then what will happen? Let's understand the fourth step. If the angle of incidence is increased to greater than the critical angle C, then it is found that there will be no more refracted ray. The light is seen to be strongly reflected. There was a weak reflection inside this case. But when we increase this angle further, then there will be a strong reflection and there will be no more refraction. Then it is found that there will be no more refracted ray. the light is seen to be strongly reflected. And as I told you, the laws of reflection will hold in this case. This phenomena is known as total internal reflection. This phenomena is known as total internal reflection. Now, total internal reflection occurs when there are two conditions that must be satisfied before the total internal reflection takes place. The first one is the ray of light passes from a denser to a less denser medium. That is the first condition. If it is not, then no internal reflection will take place. It will be from denser to the less denser medium. If you are doing the reverse of it, you will never observe the internal reflection. So the second one is the angle of incidence in the denser medium is greater than the critical angle. That is the second condition. The angle as it is denoted in this particular case, the angle of incidence must be greater than the critical angle, and then the total internal reflection will take place. This is the reflected ray. So these two conditions are there. Let us formally define the critical angle as well. So in blue rectangle, I have written the critical angle is defined as the angle of incidence in the optically denser medium for which the angle of refraction in the less denser medium is 90 degree, and that is quite understandable to you people right now. Let us turn our focus to another very important topic before discussing the application of critical angle, which will lead us to the optic fiber. So, critical angle and refractive index. What is the relation between critical index and refractive index? Now we will derive a relationship between the critical angle and the refractive index of denser medium. For this, consider a light ray going from a denser medium, say glass to air. Then what will happen? The angle of incident I is now the critical angle. When it is reflected, so it means it will become the critical angle. So that the angle of reflection R is 90 degree. That is, I is equal to C, which is critical angle, and R is equal to 90 degree. These are the two conditions we have studied few moments back. At the angle, at the glass to air boundary, and by the principle of reversibility of light. Yesterday we discussed that if we reverse the light, then what will happen? First, it was entering from a less denser medium to a denser one, but we reversed the situation and we studied that if we are throwing light from a denser medium to a less denser medium, then what will happen? And that is known as the reversibility of light. We have the equation, and yesterday we derived this equation that N is equal to sine R divided by sine I. In this case, because R is equal to 90 and this I should be replaced by C, and you must know that sine 90 is equal to 1, and that is sine c. So this implies that sine c will be equal to 1 over n, and that is very important relationship. Let us do an example and explain this relationship. There is an example for you people to understand this concept clearly. Let us understand a right angle prism, one of the angles of the prism being 90 degree. This is the 90 degree they are referring to. This figure is made of glass of refractive index 1.5. So here they given us n is equal to 1.5. Again I am repeating that there is no unit of n. So they given us 1 point. A ray of light enters the prism as shown in the figure. This one, it is entering like this. Number A part, they want us to calculate the critical angle of the prism. So critical angle is given by sine c divided by 1 over n. Few moments back we derived this. So here I am writing 1 divided by 1.5, and that will be equal to sine c. So c is equal to sine inverse and 1 divided by 1.5. So when you are using the calculator and calculate it, so you will get 41.8 degree. So this is the answer and usage of that formula. Now in the second part they are saying that complete the diagram. They given us this diagram, and that they want us to complete that after passing the red ray from the prism, what will happen. So we are going to study this diagram first. So you can see that this is the second part of that question, because it is at 90 degree as you can see from this particular location. They given us that it is 90. Whenever a ray is passing from a low a rare medium to a denser medium, it will not deviate. So it will pass through like this, and then again it will go this way, because this is 45. So this will be 45 and this will be 45, and again it will pass this and will get out at 90 degree as well. So here we can observe the light ray will enter the prism at right angle and doesn't bend. At surface AB, the angle of incidence is 45 degree. Since the angle of incidence is greater than the critical angle of 41.8 degree, there will be total internal reflection. Similarly, there is total internal reflection at the surface CA, which is this one, CA. The light ray will exit at right angle to the surface BC, as you can see that from the figure as well. So in this way we will complete, because that 45-degree angle is greater than 41.8, so total internal reflection will take place. Now we are turning our focus to another very important topic in which we will study the optic fiber as well. Application of total internal reflection, where we can find this total internal reflection and where we can get advantage of it. The first application is in the case of periscopes and binoculars. Binoculars, you can see the figures of both side by side. The figure shows a periscope. It is constructed using two right angle prism. You can see that one prism in this and the second prism is this. As we have studied in the example, it will be reflected at 90 degree, and here it will also be reflected at 90 degree. Similarly, the second ray will be also going like this. So if we are studying this object, the eye will see this object. So there are two prisms inside the periscopes, and those two are at right angle to each other. So the light rays are therefore internally reflected. Why? Because the light ray hit the inside surface of the prism at angles greater than the critical angle. So that is why it is happening. And similar situation you can see in the binoculars, that there are two prisms in which the light ray is coming from a distance and it is reflected back, and after great clearance they will be directed to the eye through eyepiece lens. There is an objective lens which is here, and there is an eyepiece lens which is here. So this internal reflection concept is totally used inside the two periscope and the binoculars. What happens actually in the binoculars? The binocular also makes use of the prisms to reduce the length of the instrument and to produce an erect image. Take note that the light rays in a pair of binoculars are bent through 180 degree by each prism, in contrast to the periscope where light rays are only bent through 90 degree by each prism. So you can see that the ray is going in this way, then they are reflected in this way, and then it is, so this is 180 degree, here it is in 90 degree. So what is the advantage of this? They reduce the size. Periscopes are very tall and longer device, so that is why we are using binocular most frequently. The second application of optical fibers is the total internal reflection is optic fiber. That is the new technology used in this modern era for telecommunication. Nowadays, the cables network coming to your home are through optic fiber. The television reception is also through optic fiber. The telephone reception or transmission is also through optic fiber. Now, optic fiber is nowadays always made up of plastics. In the early days, it was of the glass, and in the submarine cables under the ocean, they are using this optic fiber. Dear learners, whenever you are sending a message from your mobile to a far away country, for example, from Middle East to North America, when you press the send button, your message is retrieved by the distant device at the same moment when you press. So it is going very fast. This is used for fast telecommunication. In optic fibers, data is transmitted with the speed of light. So in this case, a very important application of total internal reflection can be found in optical fibers. An optical fiber is made of a core of high refractive index, glass or plastic. I told you that plastic one are cheaper one. So that is why nowadays we are using plastic. It is normally coated with glass of lower refractive index. A light ray introduced in the optical fiber will be internally reflected at the surface. Even though the optical fiber may be bent, the light will still be internally reflected. As you can see that in the figure, the rays, the light wave are going at a specific angle which is greater than the critical angle. So there will be a total internal reflection and no bit of data will get out from the optical fiber, which is very thin, thinner than the hair. So there is a question, and I told you that if it is bent, it is not like this, that always it will be a straight line from one corner of the world to the other corner of the world. If it is bending, this light will never get out from the optic fiber which is carrying data from one part of the world to another part of the world. Remember, the optical fiber are now widely used in telecommunication industries. They can carry much more information than copper wires. In the older days, the telephone industry was using the copper wire, and that were very slow. But optic fiber made everything crystal clear and very fast. They are also lighter and are becoming cheaper to manufacture than copper wires. So that was the whole story about the optic fiber. Optic fiber is another world. When you are studying this topic in greater detail, there are chapters written on this optic fiber, and you will study it in the subsequent classes. There is an announcement that very soon I am starting another course of physics very soon. then you will be notified. And that is my second channel Inforium. I will start that on the Inforium, and I will inform you and will give you the link of that channel as well, so then you can enjoy the advanced topics of this physics and mathematics in that channel. For today, we came to the end of this topic. Right after this, we will solve numerical, conceptual, MCQs types of questions on these topic we learn. So stick with me. In the next lecture, we will start the question. Thank you very much for your time. Allah Hafiz.